Hi guys, welcome back to my channel Learn to Understand, and in today's video I'm going to explain you about the concept of resistance because I've started with the chapter current electricity. If you've not watched the first part, then go back on my channel and do watch the first part for a better understanding of the second one, right? So this is basically the part 2 of the same, and I hope so you love the part 1, and because this is very important for us to analyze things, that's why I just divide everything into parts for that, so that you can understand easily, you don't have any doubts, any problems, anything that's taught first, and you don't want to hurry at all, right? So if I talk about resistance, so when a current flows through a conductor, then what happens is the wires, they offer some obstruction to the flow of that current, right? So the obstruction that is offered to the flow of current by the wire or the conductor is basically resistance. Okay. Now why do you think that resistance occurs? So a metal has a high regular arrangement of positive ions with a large number of electrons which move almost freely inside the metal. So you all know that metals, they lose electrons, thereby they are positive. They have positive charge on it. Right. So what happens is the electrons, they move freely in, means if this is a wire, the electrons will move freely here and there, here and there, here and there in the metallic conductor. Okay. So basically the electrons which are flowing, they are basically called the free electrons, correct? So they move at random, they are colliding among themselves. Means if you see this is a tube, this is a tube, let's say. So there are certain electrons, they are colliding, means they are getting banged into some, they are getting obstructed by some other things. So basically they are traveling with some fixed positive ions. Fixed positive ions means, let's suppose that this is a positive ion, so it collides, this electron, it collides with this full positive ion, right? So as shown in the figure, let me see the figure because I've drawn it myself. Let's see the figure. Yeah, so let's see. Now see, these are positive ions that are fixed. These are electrons. See, this is colliding with it. Or if we see two electrons also collide with it, this is a metal wire and any conductor, you could say. Okay. Right. Where were we? Yeah, we were here. So when the ends of the metal wire, they're connected to a cell or basically a battery or any source of current, then when a potential difference is applied across the ends of a metallic wire, then the electrons start moving from the end at negative potential towards the end of positive potential, right? They gain energy, the speed increases, and they move from negative to the positive potential side. But during the movement, they collide with the fixed positive ion. So let's see the diagram and understand. Basically, they're talking about this diagram, and when you've connected it with the cell, what happens is these positive ions, positive, positive, positive. So basically, this is a negative terminal because it flows from negative to positive. So they started moving from the negative to the positive terminal. Yeah, so this is a negative terminal because you can see the electrons are moving from negative to positive terminal of a cell. So on collision with the positive ions, the electrons lose the speed. जब धक्के मुक्के होते हैं तो क्या होता है, इलेक्ट्रॉन्स की जो स्पीड होती है वो कम हो जाती है. सो कोलिजन्स के बाद ये फिर से एक्सीलरेट हो जाते हैं क्योंकि ये पॉजिटिव पोटेंशियल की तरफ जा रहे हैं. ठीक है. सो एज अ रिजल्ट द इलेक्ट्रॉन्स डू नॉट मूव इन बल्क विद अ कंटिन्यूसली इंक्रीजिंग स्पीड, बट देयर इज अ ड्रिफ्ट ऑफ इलेक्ट्रॉन्स टुवर्ड्स द पॉजिटिव टर्मिनल. This is how the metal of a wire offers some resistance to the flow of electrons, right? Now what are the factors that affect the resistance? Let's see them, but first let's erase it. Okay, so resistance depends upon the nature of conductor, right? It also depends upon the length of conductor, thickness of conductor, temperature of the conductor. If we talk about the nature of conductor, so different substances have different concentration of free electrons, and they offer a resistance they offer the resistance of a conductor, right? So basically, what are they saying? That different substances have different concentrations of free electrons, right? Therefore, the resistance of a conductor depends upon its materials, right? So substances such as silver, copper, lead, aluminium, etc., they offer less resistance because they are good conductors of electricity. Correct? What are they? They are good conductors of electricity, but the substances such as rubber, glass, wood, paper, they offer very high resistance as they are the insulators of electricity. So you came to know an important point from here, that conductors offer less resistance, and the insulators, they offer more resistance. Correct? Now, length of conductor, the resistance of a conductor basically depends upon the number of collisions with the electrons they suffer with the fixed positive ions while moving from one end to the other end of the conductor. So obviously the number of collisions will be more in a longer conductor as compared to a shorter one. Means if I have this conductor and if I have this conductor, this is a longer one, so it will have more positive ions. If I talk about this conductor, it will have less positive ions. So if more positive ions would be there, means more collisions will be there with the electrons. So if more collisions will be there, means more resistance, and if less positive ions will be there, less collision will happen. If less collisions are present, then what will happen? Less resistance would be off, right? So in fact, the resistance of a conductor is directly proportional to the length of the conductor. The more is the length, the more is the resistance. Thickness of a conductor: in a thick conductor, the electrons get a larger area of cross section to flow as compared to a thin conductor, right? So in a thick conductor, the electrons, they get a larger area of cross section, right? What do I mean by larger area of cross section? Means larger area, right? So as compared to the thin conductor, means if I have a conductor that is somewhat like this, and if I have a conductor that is somewhat like this, so which conductor is thick? Obviously this conductor is thick and this conductor is thin, right? So a thicker conductor is going to offer more resistance as compared to a thin conductor, right? So the resistance of a conductor is inversely proportional to its area of cross section normal to the direction of the flow of current. So R is 1 by A. Temperature of a conductor, right? So with the increase in temperature, the random motion of electrons and amplitude of the fixed positive ions increases. Amplitude means the vibrations that they make, right? So they increase. So as a result, the collision also increases. So the resistance also increases with the increase in temperature. So the resistance of a filament of a bulb is more when it's glowing. That is when it is at a higher temperature, because when it is at a higher temperature it gains some heat, and as compared to when it's not glowing, that is when it is cold, because when it is cold it's not at all gaining any kind of heat, right? So I'm going to brief you up whatever we have studied, the four conductors that affect it, then I'm going to move further. I'll write it here, whatever we have studied. Just give me a minute. Yeah, so resistance is directly proportional to the length of a conductor. Resistance is inversely proportional to the area of cross section, as you can see, right? And resistance is directly proportional to the temperature. And the first one we did the material, so it depends upon different materials. Okay, let's move further now. Ohm's law, very important in this whole chapter. This is Ohm's law. So Ohm's law states that V is equal to IR. What is V? V is potential difference, PD. And what is I? I is current. And what is R? It is resistance. Right? So the current flows in a conductor when there's a potential difference, as I told you, right? So the scientist Ohm, he said that there's a relationship between the potential difference and current, right? So the relationship is stated in the form of a law that is known as the Ohm's law. So what is the Ohm's law? According to Ohm's law, the current flowing in a conductor is directly proportional to the potential difference across its end in the physical conditions and the temperature of the conductor remaining constant. You have to get this very important point. The temperature in basically remains constant in the Ohm's law, right? What remains constant? The temperature in the basically the temperature remains constant, right? And whose temperature? The temperature of the conductor. Correct? Don't forget this. So the direct proportionality between the current and the potential difference implies that if the potential difference across the ends of the conductor is doubled, right? If you double the potential difference at the end of the conductor, then the current flowing in it also gets doubled. ठीक है, जैसे हमने देखा ना V इज इक्वल टू आई आर फॉर्मूला है, तो अगर V डबल होगा, V इंटू टू होगा तो I इंटू टू भी होगा, राइट? अगर टेम्परेचर कांस्टेंट है तो रेजिस्टेंस वुड बी कांस्टेंट, राइट? So if a current I flows in the conductor when the potential difference across its end is V, then according to the Ohm's law, I is directly proportional to V, correct? So V upon I is equal to constant, right? So let that constant be R. So wait, let me write it properly so you all can understand properly. See, we have been given I is directly proportional to V. So can I say V upon I is equal to any constant? So if V upon I is equal to any constant, just let that constant be R. Basically this is it, right? That is the resistance of a conductor basically. Thus, just a minute, let me shift it. Just a minute. Okay. Shift the focus. Right. Yeah. So, okay. So V is equal to IR, right? Because V upon I is equal to R. This implies V is equal to I to R, right? So resistance of a conductor is constant at a given temperature for the given conductor, right? So if current is 1, let's suppose current is 1. So V is equal to 1 into R, because what is V? V is equal to I into R, so V would be 1 into R. So what does V become? V becomes equal to R. Thus, the resistance of a conductor is numerically equal to the potential difference across its ends when unit current flows through it. What is it, ma'am? So the resistance is numerically equal to the potential difference, because what is V? V is the potential difference. So the resistance is equal to the potential difference when the current unit means one current flow. See, this is when the unit current flows through it. So unit of resistance would be unit of this potential difference upon unit of the current. And what is unit of potential difference? It is, what is it? Volts, right? And what is the unit of current? It is ampere. So it is volt per ampere is the SI unit of resistance. What is it? Volt per ampere, right? And board with the color, let's change it. Okay, so I hope so you are clear with the unit. So the SI unit of potential difference V is volt and the current is ampere. So the unit is volt per ampere, which is named as Ohm after the name of the scientist Georg Simon Ohm, right? So it is represented by this volt per ampere. It is represented by Ohm. Sorry for this. Okay, so the resistance of a conductor is said to be 1 ohm if the 1 ampere of current flows through it with the potential difference of 1 volt is applied across the end of the conductor. So high resistances are measured in kilo ohm and mega ohm. 1 kilo ohm is 10 raised to power 3 ohm and 1 mega ohm is 10 raised to power 6 ohm, right? Now let's move on to a very important topic again, conductance. So conductance is the reciprocal of resistance. Basically, conductance means the ability to conduct the current, right? So conductance is the reciprocal of resistance, right? So its unit is, but if you write the definition as ability to conduct the current, that's very wrong. You have to write the reciprocal of resistance is conductance. So conductance is 1 bar upon resistance. So if the unit of resistance is 1 ohm, then what will be the unit of conductance? If conductance is 1 upon resistance, then 1 upon ohm, that is this. This is the unit of conductance. We write it nowadays, we do not write it MHO, that is mho for ohm, right? Basically, we call it Siemens. What do you call it? Siemens, or you can write it ohm minus reaches for minus 1. Correct? Now let's talk about the IV graph. For a metallic conductor, the ratio of V upon I is constant for all values of V and I. Right? So if a graph is plotted against the potential difference V, we get a straight line that is passing through the origin. Since the relationship between V and I is linear. Right? Now the slope of IV graph. The slope of IV graph is delta I upon delta V, which is equal to the reciprocal of resistance, right? Because what is resistance? See, if V is equal to IR, then R is equal to V upon I. But what did we get? I upon V. That is completely opposite from resistance, right? Therefore, just a minute, let me show you the page. Therefore, the slope is equal to delta I upon delta V, that is equal to 1 upon the resistance of conductor. Correct. So what is the limitation of Ohm's law? Ohm's law is obeyed only when the temperature of the conductor remains constant, and I have explained this thing to you when I was finding the resistance, right? Now, experimental verification of Ohm's law. So there's an experimental verification of Ohm's law. So you can all do it by yourself. If you still need my help, then tell me. I'll surely make a video for that, right? So let me just zoom it out. Let's zoom it out. Yeah. So something is explained here. Slope of VI graph. First we did what? Which graph did we do? IV graph. Now we are doing VI graph. This term. Yeah, this is the VI graph. So graph is plotted for V against I, taking V on the y-axis. Earlier I was on the y-axis, but now what is on the y-axis? V is on the y-axis. Okay, so slope of VI graph is to find the slope of the straight line obtained by VI graph. Take 2 points P and Q on the straight line, and it's basically delta V by delta I. Right? What it will be? Delta V by delta I would be the slope of this graph. So the slope of the straight line is delta V by delta I. So the obviously the greater is the slope of the VI graph, greater is the resistance of the conductor. ठीक है, जितनी ज़्यादा slope होगी VI graph की, उतनी ही ज़्यादा क्या होगी? Resistance होगी. Because what is V upon I? It is basically resistance. Correct. So जितना ज़्यादा slope होगा, उतना ज़्यादा क्या होगा? Resistance होगा. So if you have to make the graph, this is a very important graph which I've usually seen in papers. Basically जो तीनों graph तक आए हैं, तीनों ही बहुत इंपॉर्टेंट है, IV ग्राफ एंड VI ग्राफ, राइट? सो जब ये वाला ग्राफ आए, जब डिफरेंट टेम्परेचर्स आपको करना होता है, यू हैव टू राइट इट दिस वे, T1 एंड T2, V by I graph, right? So two conductor T1 and T2, where T1 is greater than T2, so resistance of a conductor is more at a higher temperature, right? So if T1 is greater than T2, so R1 would be greater than R2 because resistance is more if the temperature is more, and it is lower at a lower temperature. Therefore, a straight line A is steeper than straight line B, right? Steeper, देख लो ना, एक ये ज़्यादा steep है, ये थोड़ा जेंटल तो चला गया ना, इधर को चला गया, ये थोड़ा सा सीधा गया है, स्टीप हुआ है ये, ठीक है? सो जितना हमारा टेम्परेचर उतना ज़्यादा क्या होगा? रेजिस्टेंस होगा. सो ओमिक एंड नॉन ओमिक रेजिस्टर्स. अब ओमिक रेजिस्टर्स कौन से होते हैं? The ohmic resistors are those resistors, the conductors which obey Ohm's law are called ohmic resistors or linear resistors. Ohmic resistors को और क्या कहा जाता है? Linear resistors भी कहा जाता है. Examples जैसे जितने भी metallic conductors हैं, जैसे silver, aluminium, copper, iron, nitrogen, copper sulfate solution with copper electrodes, dilute sulfuric acid, etc. ये सारे constant temperature पे हैं, तो ये क्या है? Ohmic resistors, because ये Ohm's law को obey करते हैं. Right? For such resistors, the graph plotted for the potential difference V against the current I as straight line is shown at the value of resistance R is same irrespective of value of V or I. Right? That is the ratio of V upon I remains constant. Right? Now if we talk about the non-ohmic resistors, the conductors which do not obey Ohm's law are called non-ohmic resistors or non-linear resistors. Right? So examples, the diode value, diode wall, triode wall, junction diode, filament of a bulb, etc. Right? So for these devices, the graph plotted of potential difference against the current is not a straight line, but it is a curve, right? So in case of the ohmic resistors, it is a straight line, and in case of the non-ohmic resistors, it is a curve, right? So the resistance of such a conductor, that is in the ratio V upon I, is different for different values of V or I, right? So the resistance of a particular value of V or I is obtained by finding the slope of the tangent drawn at the corresponding part. You can see these are the tangents that have been drawn: tangent 1, tangent 2, tangent 1, tangent 2, right? Different tangents are drawn by the slope of V upon I. This is called dynamic resistance since its value is changing. The value of V or I is changing, therefore the resistance is said to be dynamic resistance, right? So now let's distinguish between ohmic and non-ohmic resistors. What are ohmic resistors? Ohmic resistors are those resistors which obey Ohm's law, and non-ohmic resistors are those which do not obey Ohm's law, right? So V upon I is constant for all values of V upon I, V or I in case of an ohmic resistor. In case of a non-ohmic resistors, the value of V or I is not same, right? That is the value for V and I, they constantly keep on changing. Correct, students? So let's move further, let's revise further. Yeah. So the graph for the current I versus potential V is a straight line, right? We will see that the graph is straight line, but on the other hand, the graph of this is a curve, right? So the slope, sorry guys, sorry for this. Oh wow. Sorry. Yeah, I hope it's clear now. So the slope of VI graph is same at all values of I and V, but the slope of VI graph is different at different values of V or I. Right? Example: all metallic conductors, iron, copper, aluminum, nitrogen, sulfuric acid, right? And examples: junction diodes, the diode valve, the triode valve, the transistors, the filament of a bulb. These all are non-ohmic resistors, right? Or non-linear resistances, right? So now we move on to the very important part, I could say, that is superconductors. Experimentally, it is observed that the resistance of some substances like tin, lead, they can be tremendously, sharply, they can be decreased with a very low temperature range. And the substances under this condition are called superconductors. The resistance of a superconductor is almost zero in that very low temperature range. Once a current is set up in a superconductor, the current persists for a very long time, applying any voltage. That is, the conductivity of a superconductor is infinite. Means इतनी conduction कर सकता है वो, इतनी कर सकता है, you cannot count that. ठीक है. So superconductor is a substance of zero resistance at a very low temperature, because अगर आपका temperature जितना low होगा उतनी resistance कम होगी. तो बिल्कुल ही low temperature पे we are getting superconductors. ठीक है. Now let's move on to specific. Okay, wait. The superconductors should be very useful. It could be possible to obtain them at room temperature. The size of the computers could then be reduced to a few centimeters, and power lines for a city should be made as thin as a single cable. Wow. Interesting fact, no? Okay, specific resistance or resistivity, an important topic again. So resistance of a wire is directly proportional to its length. We've learned it. So the same wire of the double length is taken and the resistance of the wire gets doubled. Correct. So the resistance of a wire is varies inversely as the area of cross section of the wire. That is, R is inversely proportional to 1 upon A, right? So where R is the radius of the wire. So if a wire of the same length but of double radius is taken, then the resistance is found to be 1/4. Means it has double radius, right? Length is same, the radius is doubled. So if we know that R is inversely proportional to A, if this is doubled, then this would get be A square, then it would have been 1/4, right? So if the radius is tripled, then it will become 1/9 and so on, right? So R is inversely proportional to A, and if you combine that, R is equal to rho LA. Now why did I write L here? Because it is constant. R is directly proportional to, not constant. I'm very sorry for that, I used the wrong word. R is directly proportional to L. That's why you can write L by A, or you can write rho L by A, right? That is rho upon L by pi r square. Because what is area? It is pi r square. So here the rho is constant, which is called the resistivity or specific resistance of the material of the wire. From above relation, resistivity is the resistance into area upon the length, right? So if length is 1 and area is 1, then the resistance is equal to resistivity. So resistivity of a material is the resistance of the wire of that material of unit length and unit area of cross section. What is resistivity? It is the resistance of a wire of that material of that unit length and unit area cross section. It is a resistance of a wire of that material of unit length and unit area of cross section. Okay. So R is equal to rho L by A. It is evident that if wire is stretched and its length gets doubled, its area of cross section gets halved, and since the volume remains unchanged, so its resistance increases to 4 times its previous value, twice because of the increase in length and twice because of the decrease in the area of cross section. So if a length increased to 3 times the stretching on the wire, then the resistance becomes 9 times. That is, if a wire is doubled and its length is halved, right, and area of cross section is doubled, so the resistance becomes 1/4 of its previous value. So unit of resistivity is P is equal to rho is equal to R into A upon L. What is the unit of R? R is what resistance, that is ohm, into what is A? Meter square, or what is L? Meter. Meter square get cancelled. So the ohm meter is the unit of resistivity. So that's the unit of resistivity is ohm into meter or ohm meter. Now what are the factors that affect resistivity? So resistivity it's affected by the material of the conductor and the temperature of the conductor. Right? So resistivity is less for a good conductor and is large for a bad conductor. Right? Resistivity is good for a bad conductor, and it is basically resistivity is large for a bad conductor and less for a good conductor. Right? So dependence of resistivity on temperature. The resistivity of metal increases with an increase in temperature, while for a semiconductor it decreases with the increase in temperature. So for conductors, the resistivity basically it increases, meaning it is directly proportional to temperature. Resistivity is directly proportional to temperature. But if we talk about the material of conductor, then resistivity is inversely proportional. Means if the conductor is a good conductor, then the resistivity is less. If it is a bad conductor, then the resistivity is more. Right? Let's see further if there's something to be done. Yeah. Difference between resistance and resistivity. But before that, let me explain you the note. The resistivity is independent of the shape and size of the conductor. It's a property of material that is used. It doesn't depend upon the applied potential or current. If a wire is stretched to increase its length, it is doubled on itself. The resistance of the wire will change. The resistivity will remain unchanged. Right? Now let's see. Resistance of a conductor is the obstruction offered by the conductor in the flow of current through it. It is measured by potential difference needed to cross the current to flow, while a flow 1 ampere current through it. Right? R is equal to V by I. So resistivity is the property of conductor due to which it offers resistance to the flow of current through it. This is the best definition I could recommend for you to you for writing in the paper. You can resistivity is the property of conductor due to which it offers the resistance to the flow of current, right? It is measured by the resistance offered by 1 meter length of wire that the material large area of cross section. And as you can write the formula that P is equal to R into A by L. So the resistance of a conductor depends upon material, temperature, length, and area of cross section. The resistivity depends upon the material and temperature only. It is independent upon the it is independent of the area of cross section and the length, right? Now let's talk about the SI unit. The SI unit is ohm and the SI unit is ohmic meter, right? So conductivity. The reciprocal of resistivity is conductivity. It is represented by signals, the symbol sigma, right? So this is what? This is sigma. It is 1 by this and it is L by RA. Right? What is resistivity? RA by L. What is conductivity? It is L by RA. Correct. Let me erase all this and let's change the pen's color to which should I take? Yeah, yeah. Okay, okay. Sorry for this. So SI unit would be 1 upon ohm into meter. What is that? Ohm per meter. Right? Ohm 1, ohm is minus 1, meter is per minus 1, or you call it Siemens meter minus 1. So choice of material of a wire. The choice of material of a wire depends upon the purpose for which the wire is to be used. Right? So the wire which are used for electrical connections and for power generation are made of materials such as copper or aluminium, for which the resistivity is very small. Right? Copper and aluminium wires are basically preferred because the resistivity offered by them is very small and they are made thick so that the resistance can be considered to be negligible. जितना thick होगा तो क्या होगा उतनी resistance जो होगी negligible हो सकती है. Sorry. So on the other hand, the resistance wires are made up of materials such as nicro, manganese, and one constant for which the resistivity is quite large and the effect of charge and temperature on the resistance is negligible. So fuse wire is made of an alloy of lead and tin because its resistivity is high and melting point is low, right? Fuse wire lead and tin से बनी होती है. So variation of resistance and resistivity with temperature. For a metallic conductor, the resistance increases with an increase in टेम्परेचर है ना. हमें पता है मेटालिक कंडक्टर से जितना टेम्परेचर बढ़ेगा तो उतनी रेजिस्टेंस भी इंक्रीज हो. ठीक है. सो द रेजिस्टेंस ऑफ अ फिलामेंट ऑफ अ बल्ब इज मोर व्हेन इट इज ग्लोइंग than when it is not glowing. मेरे को पता है जितना टेम्परेचर ज़्यादा होगा कि वो हीट हो जाता है बल्ब जब वो ग्लो कर रहा होता है तो मतलब कि रेजिस्टेंस भी उतनी ज़्यादा होगी. एंड जब वो बल्ब ग्लो नहीं कर रहा है दैट इज उसका जो टेम्परेचर है वो लो है, मतलब कि जो हीट है वो कम आ रही है तो वो कोल्ड होगा. अगर कोल्ड होगा तो रेजिस्टेंस लेस हो, राइट. सो द स्पेसिफिक रेजिस्टेंस और रेजिस्टिविटी ऑल्सो इंक्रीजेस विद एन इंक्रीज इन टेम्परेचर. For alloys this constantan and manganese, the resistance and resistivity remains practically unchanged with an increase in temperature. For semiconductors, the resistance, some are semiconductors, carbon, silicon, germanium, the resistance decreases with an increase in temperature. Okay? Right, so finally we've done this. No, the chapter is not done. It's not that the chapter is done, chapter is left. But for today's video, I think this much is all right. And I would like if you to practice the first question, right? And I will start with the first question in the next video. Let's explain this question to you all. And guys, do like the video if you thought that this video provided good content to you. And if you want some videos for chemistry also, then go check in my channel. I've posted the videos for nomenclature. Also, I've posted the videos for the what was it? The chapter chemical bonding chapter. I've posted the videos, do check them out. And if you need help in math set chapter, then I've posted the videos for that also divided into 9 parts. And if your spoken English is quite weak, then kindly go and check my channel. I've provided with good amount of videos for spoken English, and I'll be uploading more videos soon also, because let me first be free from this all. And do like my video, do subscribe to my channel for more such videos, and do give me suggestions if you want to give me in the comment section below. Do tell me your doubts in the comment section below, and do share the video if you think that this video would be helpful for others too, and do press the bell icon if you want to get notified at the first when I post a video. So thank you for watching the video, and if any doubts then please tell me. Don't keep any doubts in your mind, right? Meet in the next video. Thank you and bye bye.